All right, the last page that we're going to take a look at is how to transform polynomials. So we've already done this before, so this is not any different than any other transformation. I do understand that it can be a little bit challenging to interpret the transformation. Now, you've seen this general equation before, all right? Notice how this says f of b parentheses x minus c plus d. So basically what this is saying is you have your a value. Okay, this bracket can be any sort of grouping symbol. It can make it x to the third, x squared, x to the fourth, whatever. So these transformations work for any type of polynomial. All right, so just keep that in mind. All right, they work for any type of polynomial. And like I said, this just pretend like here's your grouping symbol. This could be a square root sign. This could be parentheses squared. It doesn't matter. They all mean the exact same thing. All right. So anytime you have something inside the parentheses, this is just like what we did with quadratics. Okay. It's not any different. Anytime you have something inside the parentheses, it moves the graph left and it moves the graph right. Now, remember, if your number is positive, it's right, and negative, it's left. But since you have this minus sign here, you must take the opposite. Remember, you're always going to take the opposite of what is next to x, okay? So take the opposite, and then if the opposite is left, it's negative. If the opposite is right, it's positive, okay? Your number added or subtracted at the end, remember, moves your graph up and it moves your graph down. Remember, if it's positive, it's up, and negative, it's down. So just like the parabola, the number added or subtracted at the end moved it up or down. This one, you do not take the opposite because this is a positive value here. Okay? All right, now what the a in the polynomial does is that affects the end behavior of the graph. And what do I mean by end behavior of the graph? So remember, this a value is going to stretch it. It's going to make it wider, okay? So your end behavior is, for example, if this was your original graph, okay, if we are stretching it, okay, or we are making it wider. So the end of it, so this would be your original graph. The ends of this one is not going up as fast. The end of this one is going up much faster. Okay, so it's a vertical stretch. Okay, remember, if a, the absolute value of a is bigger than 1. So when I say the absolute value of a, you're just going to take whatever here because the negative reflects it about the x-axis. So you're just going to look at the absolute value. So just think of any number that's bigger than 1 or less than negative 1. All right, and that's going to give you that vertical stretch. It's going to go up faster. Okay, it is a vertical compression. Okay, if the absolute value of a is less than 1. All right, and when I say the absolute value of less than 1, that means that a is between -1 and 1. So think of this as a fraction that's not bigger than 1 or smaller than 1. So this is your vertical compression. This is your vertical stretch, okay? So b, remember this b value right here this is your horizontal stretch and your horizontal compression. And remember, it's just the opposite of your vertical stretch and your vertical compression, all right? So your value of b, you're going to have a horizontal compression, okay, if your absolute value of b is bigger than 1. So horizontal compression, it's the opposite, remember? So vertical stretch is the same as a horizontal compression, all right? And it's going to be a horizontal stretch if the absolute value of b is less than 1, okay? The opposite, a vertical compression is a horizontal stretch. And this is, remember, this is just b being between -1 and 1. So that same thing that you have up here with your vertical. All right, I know that that's a little bit tricky, but so this right here was a vertical stretch and a vertical compression. This is a horizontal stretch, okay, because it's being stretched horizontally back and forth. Think of like a rubber band, you're stretching it horizontally. This right here is a horizontal compression. Think about taking your horizontal axis, folding it in half, and it's actually going to sort of smush it and make it look thinner. All right, so let's just take a look at some examples. All right, so you have y equals x to the fourth. So what we're going to do is we're going to make a new equation based on this transformation. Okay, so the first one says moved 2 to the left. So remember that transformation is x minus c. So move 2 to the left is -2. So that's why that's going to be f of x plus 2. Okay, so this x plus 2 right here, remember next to the x is always your it's your horizontal movement left and right, okay? Now, we have our original function, which is x to the fourth. So if I want to move it 2 to the left, that's your x plus 2. So how you're going to write that is going to be y equals x plus 2 to the fourth. Notice how this says f of x plus 2. So this just means I'm taking my function, wherever I have an x value, I'm going to replace it with x plus 2. Okay, so here's my original y equals x to the fourth. Wherever I saw an x, I'm going to replace it with x plus 2. Okay, all right, so take a look at the second one, moved it 2 up. Remember, you take your original function and the up and down movement is the number added or subtracted at the end. All right, so here's my original function, x to the fourth. So that plus 2, I'm just going to take that entire function and tack 2 to the end of it. Okay, and I move 2 down. So there's your transformation right here, minus 2. It's your entire original function, and then you're going to subtract 2. So here's my original function. I'm going to subtract 2 from it. So y equals x to the fourth minus 2. Okay, and then moved 2 to the right. So remember, like we said, moving to the right and the left is the opposite. So it's x minus c. So this is a positive 2, but when I plug in a positive 2 here, it looks like minus 2. All right, so move 2 to the right. So basically, you're going to say f of x minus 2. So everywhere where you see an x, you're going to replace it with x minus 2. So this is going to look like x minus 2 to the fourth. Okay, so this is going to tell me this is moved 2 to the right. Remember, you always take the opposite. Okay, now notice how this says opposite end behavior. So your positive a value out front keeps the original end behavior. If you make that a negative, okay, that is what is going to cause that opposite end behavior. Okay, then we have a vertical stretch of 3. So let's just take a look at our general equation. So our general form of transformations is y equals a times the f of b times x minus c plus d. All right, and let's just kind of fill this in piece by piece. All right, so opposite end behavior. So we know that this a has to be negative. All right, vertical stretch of 3 means that this a value is going to become a positive 3. Okay, now a horizontal compression by a factor of 2. Okay, so compression, so that means that's going to change my b value to be 2. All right, now notice I don't have any horizontal or vertical movement. Okay, so if I don't have any horizontal or vertical movement, what this is going to look like is the c value is basically 0. I don't need it. And the d value is 0 because I haven't changed it at all. So it's y equals, I took -3 times the f of 2x. Now, this is a little bit trickier here. All right. I am actually just going to erase this for a second so we can see this a little bit easier. Okay, so you have your original function is y equals x to the fourth, okay? So that x to the fourth is our f of x. So we're taking -3 times the function, and then everywhere where we see an x, we're going to replace it with 2x, okay? So we're taking -3 times f is my function, and everywhere I see an x, I'm going to replace it with 2x. So what that's going to look like here is I take the -3 out front. Okay, everywhere where I see an x, I'm going to replace it with 2x, and I'm going to raise that to the 4th. Okay, now what you could actually do is you could actually simplify this right here and figure out what your vertical compression could be, or vertical stretch, because you could do 2x to the 4th, multiply that out, 2 to the 4th, multiply that by -3 and see what that vertical stretch would actually end up being, okay? All right, so now let's take a minute and let's do this with some tables. All right, so this is your function f of x. These are your x values. These are your output or your y values. All right, now what you're going to do when you look at the table is you're going to determine what kind of transformation you have here. So let's take a look at our first table right here. So this says f of x plus 3. So remember, if it's next to x, we're going to do the opposite. So this is going to be a -3. So that's going to tell us that my graph is moved 3 to the left. Okay, now let's just think about this. If I have a point, okay, so let's say I have the point -4, 1, 2, 3, 4, 5. Okay, -4, 5. All right, and I move that graph 3 to the left. What value is that going to be affecting? That is only affecting my x value. So I'm going to take this whole thing, I'm going to move it 3 to the left. What's that going to become? -7. Is my y value changing at all? No, it's staying at 5. Okay, so this transformation right here is only affecting your x values. It's not affecting your y's. Your y's are still going to be exactly the same. All right, so in my table, I'm going to just copy my y values. Sorry, this is kind of messy. Okay, and then my x values, since this was moved to the left, I'm going to subtract 3 from each x. Okay, so this is going to become -7. So basically you're taking each of these and subtracting 3 because you're moving them 3 to the left. All right, this is going to become -7, -5, -4, -3, +2, +5, and +3. Okay, so what I'd like you to do for this next example is I would actually like you to try these on your own. I'll explain how to do the first one, and then once you're done, just take a minute and check your answers on Schoology, or you can check your answers on here. Okay, so this one graph right here, what you're going to do is notice how this says f of x plus 2. So first identify the transformation. So this, take the opposite of what here, this is going to be left 2. So left 2 means you're going to just take every single solitary point that you have and you're going to move each of those values left 2. All right, so you're taking each of those values and moving your graph left 2. Okay, and then you're going to kind of connect your dots to see what your new graph looks like. Okay, I just took each of those values and I moved them to the left 2. All right, this +1 right here, what does this do? This is going to move your graph up 1. So all you're going to do is take every single one of these values and you're going to just move them up 1. Okay, now if you wanted to figure out what the ordered pairs were here, think about this for a second. Okay, this one, this up 1 would only change, okay, it's only going to change your y values. Okay, so basically what you're going to do is you're going to add 1 to each y value. All right, now let's take a look at the 2 down here. Now, this one's a little bit tricky. So this says 2 times f of x. So what is this doing? This 2 is actually multiplying the final answer by 2. So this is going to multiply all of the y values by 2. Your x values are not changing at all. It's multiplying all of your y values by 2. Okay, so what you could actually do here is you could write out a list of ordered pairs, multiply all of these y values by 2, and then graph them here.